So today I'm going to be talking about APIs and statefulness, and I kind of titled it, Don't Be Afraid to State in Your APIs, because I'm going to talk a lot about how you kind of need to pick the right solution for your project. So first, a little about me. My name's Eric Glasser. I'm founder of Minerva, which is a dev shop and consultancy in Denver. We've been around for about 4 months now, and just been doing a big range of projects, anything from mobile to e-commerce to API work. And so I wanted to do this presentation to talk a little bit about the findings from that, and a little bit about from kind of my previous careers and things like that. If you want to follow me on Twitter, I have my Twitter handle, and then I have some business cards up here if you want. So kind of talking about how applications that we write used to be. It used to be much more of a simple architecture. You had a database, backend language, and a client side. And I'm sure we've all done this with WordPress sites or anything that's kind of a one-off. And these were great because you only really had to maintain one piece, and your backend would manage log in, log out, everything. You didn't really have a lot of complexity. The problem is when you're dealing with modern systems, anything from kind of an enterprise integration or really just a lot of the new products that require a lot of API work, it gets a lot more complicated. And so in order to demonstrate this, I'm going to talk about a client I worked on who was a dental site. And just to show for a dental site that had, in order to get on the home page a few statistics about their local office, how much infrastructure we had to go through. Just on their side, they had an AS400, which is, if any of you know what that is, I'm sorry. It's a little bit of a legacy system. They had a SQL server caching it. They had data sync. And then in the middle, in order to add this web layer, we had to create our own data store. We had to use a CDS, it's basically a CMS without a front end, an API layer in order to translate the AS400, and then a second data store for the CDS. All of that doesn't even encompass the original server-side, client-side that we had in the first diagram, which we see here. Now, as we've seen in other talks, and you all know, it's no longer kind of this read-only data. Everything has to go, everything has to talk to everything. These all are interdependent on each other. This is the only one that kind of remains the same in that it goes from web server to front end. But then you start looking at the big picture and you have all these connections. And the problem here is that it becomes almost impossible to scale this or to maintain it, because you have an AS400 with in front of it SOAP services written in VB. You have MS SQL databases, MySQL databases, CMSs, and all you need on the client side is to schedule an appointment or get statistics. The other problem here was we couldn't store any PII anywhere in this middle layer because it would create it created a liability issue. So we went the route that everyone goes of creating a completely stateless API where you transfer state. And we did all of that just to create, as I said, this home page with these 3 statistics. Just these 3 statistics were about 12 API calls. So that doesn't work because going through all those layers, you end up, each call taking anywhere from 1 to 3 seconds. And yeah, you can parallelize some of it, but a lot of it's dependent. And the first time the page would load, this would be a 12-second page load. So in order to, and keep in mind, we can't cache any PII in the middle, which means that we couldn't even cache what their local office was. So in order to do this, we ended up ended up spending 2 months coming up with a way to basically pseudo store state in the front end, and built an abstracted data layer in Backbone based on promises, which, if anyone's worked with Backbone, Backbone doesn't make it easy to work with promises. They want everything to be event-based, which works great when we don't have interdependent data. We ended up having to encrypt things in multiple cookies and pass them through, and it was a mess. And just for this stack, as I mentioned, we had PHP, we had front-end code, we had Node.js, we had a CMS, Visual Basic, and ASP.NET. So I talked a little bit about state, and I want to kind of talk about what it is. And as we joked before, state, I'm not referring to Colorado. But first I want to talk about there's two different types of state. And the first one is resource state. This is a lot easier. This is referring to images or documents or content on the site, really anything that's not user specific. This type of stuff is very traditionally managed in the back end. Front end never managed it, just because you need this to be the same across all, everyone receiving the data. But it becomes a lot harder when you get into session state or really user specific content. Because now you're not just serving the same page. People expect when they log in to see content customized to them. You need to do stuff based on their location, and you need to pull in their user profile. This stuff becomes very difficult to cache and very difficult to even predict, because you don't know how many users are going to be accessing it. I mean, over time you can use some type of intelligent caching and do that, but for something like this site, or even a lot of the ones we work on that don't become these big platform plays, you really can't intelligently cache this user information. And it's just because let's say you have 1 million users, your cache store is going to increase linearly with the number of users you have and their number of interactions with the site. So what is stateless? Again, not Washington, D.C. Well, they are stateless, but in a different way. There's a couple different kinds of stateless, and it's a little bit of a misnomer. A lot of people get into this stateless APIs because the REST standard came out, and you have the ST in it, which is state transfer, and it's this idea that each API call should be completely independent and have no concept of basically where the user is, and this is really great when you're trying to build a normalized system, but it's really hard when you're building web. A lot of newer frameworks have made it a little bit easier, but it means that every time you load the page, you now need to basically use whatever token you have to check the state on the back end. I talked a little bit about stateless APIs and state transfer, but basically the idea here is, because front ends are not secure, you can't reliably store in local storage whether or not this person's logged in. You have to go back to the data. You have to go back to the data layer. You have to go back to the back end. And because of that, you put a lot of overhead in kind of just auth checks. And that's kind of the problem with a lot of the stateless methods we use, is it puts a lot of that overhead on the front end to keep checking to see if the person has access to something. So we talked a little bit about pushing state to the client, and I talked a little bit about the application I had, and we're seeing a lot more with single page applications, people moving towards RESTful services and then using something like Angular and resources on the front end. And this works, it makes it really fast to rapidly prototype. It actually kind of separates your data layer and your front end really nicely. The problem comes in when you try to cache or scale this. And then that's just web. Now you have mobile applications, and in recent years you have these embedded systems. The embedded systems are a little bit easier in the sense that they're usually one-off calls, but you have to deal with a whole different level of scale now, because it's not just how many times is someone visiting your web page, it's how many times is someone clicking on the coffee maker a day, or anything like that. And you end up with a lot more signal that you need to basically take into account. So just talking about two really common client needs or client-side needs that become a really big hassle when you have these perfectly normalized stateless APIs. And one of them is a comment feed. I'm sure you guys have worked on an application where they say we need a comment, we need or a post feed. We need a post or a comment feed that has the number of people who have liked it or the number of people who have interacted with it in some way. And we want to bring in all of that, and we're going to do 15 posts. And suddenly you look at your normalized API, and the post API it doesn't have the username who made the comment of the post, so it just has the ID. So now you need to make a call for that. It doesn't have the number of comments, so now you need to make a call for that. And let's say it has one more piece of information, which is not uncommon. Let's say it's likes and replies. So now for each individual post or comment, you have to make 4 API calls. And what that means is when you're up to, let's say 10 to 15, which is not a lot to show on a first lazy load, you're dealing with 40 to 50 or plus API calls, and modern browsers can parallelize that. They can do it really well, but you're still running into a lot of latency issues. And the latency issues become a bigger deal when you're talking about device-specific design. And this is because generally you end up with a lot more data-rich, calls on the website, but very often on mobile they want something completely different. And so now you have a whole different combination of API calls. And both these clients can work in that pretty well. But let's say you have a very properly cached API that you're just dealing with network latency. You're probably dealing with 150 milliseconds per API call, which doesn't sound like a lot, but when you're talking about 50 of them and a browser can only make 4 at a time per domain, or node can only make 5 at a time by default, or I'm not actually sure the limit on iOS devices or Android, but the idea is you end up creating this queue that first page load, you can kind of lazy load in the data, but the real load time, you're getting into 10, 15 seconds. So I talked a little bit about scale, and I want to kind of talk about understanding it, because scale means a lot of different things to different parts of your application. You talk about resource scale, where static scale, where you're talking about images, and that's a lot easier to scale because you can just throw it up on a CDN and you pay for bandwidth. It's not necessarily that cheap to scale, but it's easy to, because you're really just dealing with a very simple kind of interaction. The hard part comes in when we talked about that per user scale, and now all of a sudden, let's say you're having someone log in with Facebook, and then you need to pull a couple of their APIs and pull data from a few different of your, back-end services, and, which part of that do you scale? And it becomes this mess, because in your application, you're just adding these API calls that only, eventually have to happen in sequence. That slows down your application. So, one of the ways to solve this is to cache different pieces of it. But when you're talking about, your front end, you can't really dynamically cache a lot of this stuff. So let's say, going back to the doctor's example, you have a user that has a local office, and you want to cache that call. Well, you can't cache the call for that user because they can change offices. They can, you don't know how many are going to log in. But you want to cache that doctor's information, or the office information, and it's really hard to do that when you have kind of a spread out backend, where you want to cache very specific parts of an application. So the way I've solved this in a lot of applications is creating what I call a middle tier. I think it's somewhat similar to the reactive layer that they were talking about yesterday, and there was another presentation talking about similar stuff. But the core idea of this is having kind of one translational layer that connects all of your back-end services to your front-end clients or client devices. And the beauty of doing this is it allows you to first kind of segment your APIs in that if you have a different need for your iOS device than you need for your web device, you can build into this middle tier a way to serve that content differently. And here's really where you start denormalizing that data and making these combine and stuff in your JSON and things that, you know, from a traditional sense you think are terrible from a resource sense because of kind of maintainability and long term, but it's really being done at this translational layer. So now all of a sudden when someone opens up the mobile app, they can download all the data they need in one large pull, and then maybe they'll make, you know, subsequent smaller resource calls later. And when you load the home page, you can kind of chunk data together. You can, you know, cache different parts of it. And the big benefit here is you use this layer to manage your sessions. So when you're dealing with web, I still think cookies are the better way to do it. A lot of people disagree with me in terms of weight, and I know people disagree when you, and this is true when you get to the scale of like a Facebook or something like that, that cookies can become an issue. But when you're talking about a lot of the applications we're building that aren't, you know, serving 150 million people, I still think cookies are the better option because it allows you to, in web at least, make it so the front end doesn't need to care whether or not you're logged in. It just requests a resource, and cookies are able to kind of handle that a little bit more invisibly by leveraging what the browser already does. The other big part of this is by having this middle tier, you can still have your backend services be very modularized. You can have a CDN, you can have a user service, you can have a post service, you know, and what this allows you to do is maintain much smaller chunks of code, and then your middle tier combines them all so for your client devices. It can also have them have the backend services talk to each other, but it allows you to separately maintain all of this, and then because you can separately maintain them, you can independently scale them, which saves a lot of money in the sense that, you know, if you have one person accessing a certain piece of your site that, sorry, not one person, you have users constantly using a piece of your site, you can scale that backend, you know, vertically or horizontally, however you're set up, without having to affect other pieces of it. You know, let's say, you know, you don't have a lot of users, but they're doing a lot of actions. You could theoretically scale the part of your backend that handles whatever actions are common and then keep your user part small. And this makes it a lot easier to maintain because it makes this middle layer, you know, backend or kind of agnostic to that, where let's say you're using Salesforce and then you get a call and you need to now use Sugar, or I can't remember what they changed to, but another CRM, Microsoft CRM. You can now change out in your middle tier all that translation without ever touching your front end code. But the big takeaway of this is that's talking about kind of larger distributed systems, and the reason why I kind of say to stop being afraid of this is when you're working on a lot smaller projects, a lot of times it does make sense to go with the session state, to go with a denormalized API for the sake of development time and for the sake of kind of ease between the front end and back end team. And you know, a lot of that's understanding it. So when I worked in the ad world, we'd regularly have a campaign that would only run for 30 days. And if you have something that's running for 30 days and you're developing it for 90 days, but you're not going to have to maintain it past that 30 days, it's not worth spending, you know, another 2 months just to kind of make this, you know, cleaner for the future when it's just going to be scrapped after that. And so it's kind of pick the best tool for it. And that goes along with kind of when you're needing to understand the best tool, you need to understand kind of separate the product requirements from the technical requirements. We very often as developers get a requirement from product or from design, and a lot of times, we look at it and say, well, this is feasible, this isn't, or, and we have to do that, and we definitely have to wear the hat where we give back suggestions, but sometimes when there's a product requirement, when there's only 5 product requirements that has to do X, Y, and Z, it's better to get the project done to do X, Y, and Z than implement this whole new framework that you think that you really wanted it to do A, B, and C. And sometimes that's hard, and hopefully we get to work on more projects that we can do A, B, and C. But I guess my point is just to understand, which, depending on the project, which one's more appropriate. And the final one goes with the product one is kind of what are your KPIs? And, as a developer, it's important when figuring out what to scale, what you need to get, focus time on, what you need to cache, what are the kind of key performance indicators, and what do you actually need to improve on it. It makes it a lot easier to do that than saying I just need my whole application to be faster. If you're dealing with an e-commerce site, then one of your KPIs would be how many people are getting from getting into the site to checking out, and really focusing your efforts on that, and not necessarily focusing your efforts on scaling up the blog to have a video carousel. And yeah, and that's why you shouldn't be afraid to state in your APIs.